Imagine meeting someone who always has an answer, no matter what you ask. The capital of a country, your company's leave policy, yesterday's stock market news. They answer instantly. But there's one problem. Sometimes they're completely wrong. And yet they sound incredibly confident. Welcome to one of the biggest challenges in artificial intelligence. Hallucinations. To understand why AI hallucinates, we first need to understand how large language models work. Think of an AI model as a student entering an exam hall. The student has spent years studying. They have read millions of books, billions of web pages, and enormous amounts of information. But once the exam begins, they cannot open new books. They can only answer from memory. That's exactly how traditional language models work. They answer using patterns learned during training. They don't actually search the internet every time you ask a question. Now imagine a company. Not 10 documents. Not 100. But hundreds of thousands. HR policies. Training documents. Contracts. Operating procedures. Internal knowledge bases. None of this information existed in the AI's training data. So when an employee asks, "How many leave days can I carry forward?" the AI has no idea. It either says "I don't know," or worse, it guesses. What if the AI could check the documents first? What if before answering, it could search, read, understand, and only then generate a response? That's exactly what RAG does. Retrieval-Augmented Generation. Or simply, search first, answer second. Let's break down the acronym. Retrieval means finding relevant information, like searching for a specific page inside a giant library. Augmented means giving that information to the AI. Think of handing the student an open textbook. And generation means creating the final answer. Together, these three steps create a smarter and more reliable AI. Let's see what happens behind the scenes. First, documents enter the system. These documents can be PDFs, Word files, web pages, emails. But there's a problem. AI systems can't efficiently search a massive document all at once. So the document is split into smaller pieces. This process is called chunking. One large document becomes hundreds of smaller chunks, making it easier to search later. Now comes one of the most important concepts in RAG. Embeddings. Computers don't truly understand language. They understand numbers. So every chunk of text is converted into a mathematical representation, known as an embedding. Think of embeddings as GPS coordinates for meaning. Sentences with similar meanings end up close together, even if they use completely different words. These embeddings are stored inside something called a vector database. Instead of storing information alphabetically, it stores information based on meaning. Documents discussing similar topics are positioned near one another. When a question arrives, the system can instantly locate the most relevant information. Suppose an employee asks, "How many vacation days do employees receive?" The question itself is converted into an embedding. The system then searches the vector database, not for matching keywords, but for matching meaning. Within milliseconds, it identifies the most relevant chunks and retrieves them. Next comes the magic. The retrieved information is attached to the prompt. The AI now receives both the user's question and the relevant company documents. It's like giving the student the exact chapter needed for the exam. Now the model doesn't need to guess. It has the facts right in front of it. Finally, the language model generates an answer. But this time, it's grounded in actual information. The response is based on company documents, policies, manuals, knowledge bases, not assumptions. And that's why RAG dramatically reduces hallucinations. The simplest way to understand RAG is this. Traditional AI is like a student taking a closed book exam. They rely entirely on memory. RAG is like a student taking an open book exam. They can consult trusted sources before answering. And that's a huge advantage. Today, RAG powers some of the most useful AI systems in the world. Enterprise chatbots, customer support assistants, legal research tools, healthcare knowledge systems, and internal company copilots. Anytime AI needs access to fresh or private information, RAG is usually working behind the scenes. Remember, a traditional AI answers from memory. RAG answers after checking the facts. And that simple idea has transformed AI from a clever guesser into a powerful knowledge assistant. That's the power of Retrieval-Augmented Generation. Thanks for watching.